Give me like 30 seconds. Zoom updated between classes and it's it messed something up. Math problems all in the same idea of pay raises as a percentage, something that we'll get onto more in later in the semester with Math 154 and of course in here. But I felt like this would be a good opportunity to do something else in Excel that would have some aspects that were similar to the TV loan problem that we went over in my Math 154 class. So if you aren't in my 154, then you'll see something kind of similar to that where we'll use cell references in good ways, whether they are normal references or fixed references. So again, we're going to go over some pay raise problems. We're going to compare different starting salaries. We're going to compare different pay raises over different amounts of time and just see if we can make some analysis out of this as well as learn to appreciate Excel just a little more. So again, I'll be in the chat in a few minutes if you have any questions as we're going along. But besides that, here we go.
And we're going to do a little bit of finance. I do a lot more of this later in the semester, but there's nothing wrong with introducing it now. We've already really introduced the main way things are done in Excel with this kind of finance when we were doing the $1,000 TV loan, how we had to have an original balance for the month, an interest for the month, the ending balance for the month, and then just keep looping through. So, example, we got Bob. Bob makes $25,000. The day he starts his new job as a MyMathLab repair person. We'll make that a little silly joke just to go with the time. So Bob is making $25,000 per year. Let's be more specific and say per year. Generally, when you say someone's salary as a flat dollar amount, that's usually stating an annual salary. If I had said something like $8 or $14 or $10, that probably would have been a per hour situation. Now, of course, these are blanket statements that are usually true, exceptions to every case, but I want to be explicit. Bob makes $25,000 a year the day he starts his new job as a MyMathLab repair person. And maybe that low salary is why they're stagnating on the repairs. Obviously, all jokes. We love MyMathLab. We couldn't do any of this without them. So hopefully they can take a light joke or two. But the MyMathLab people, the MyMathLab crew, will give Bob a 3% raise every year, no matter what. Don't we wish it was true in general? As a state employee, I can tell you we don't even come close to that in terms of the percentage or the every year aspect, but again, not the point. Just that, hey, it's nice when you can find a job that guarantees a raise every year, but do not expect that for most jobs. 2%, getting a 2% raise isn't even really a raise at the end of the day because that's the average inflation rate. That just makes sure you can still continue to buy the same things you've been buying if you're buying inflation adjusted goods, which we'll get into that in a later chapter. Because not all prices inflate equally. For example, computers have actually gone down in price over time. It's much easier to buy a computer now in 2020 versus in 1995, where a desktop would cost you $2,000. In 1995, when the dollar was even more valuable, salaries were lower, much more difficult to buy a computer then, which is why people didn't own computers as often. All right, so how much money Bob make the year 2035, assuming his first day was January 1st, 2020. Bob didn't even know what he was getting himself into. This is pre-COVID-19 hitting American shores. So we want to know how much money will Bob make in the year, so per year, an annual salary in the year 2035, assuming his first day was January 1st, 2020. So did I close it? I certainly did. Give me 2 seconds. More than 2 seconds, probably. There's the template. So this is basically all we really need in terms of columns for this problem. And instead of months, it'll be years. We'll have a column for the beginning balance. We'll have a column for the interest, which instead of calling it interest, we'll call it raise. And then the new balance will be his new salary at the end of the year. But we're just going with this same 4 basic things. We'll have a column for the time, which will be in years this time for this problem. We'll have a column for his beginning salary, a column for how much he's going to get as a raise, and then a column for his ending salary. Now, we can label things to the side if we like and use cell references, which we will. We could be a little more stubborn and put the percentages and numbers just directly in here. But again, let's try and set something like this up. And let's do this completely on the fly, so I'm not going to use a template. Zoom in just a little bit. So we'll have the first column be month, year. We'll have the second column be the starting salary. We'll have the second column be his raise at the end of the year. And then a column for his new salary, or the salary next year, specifically. So when I set those 4 columns up, there's a lot of things running together. We can widen our columns by going between the letters. Now remember, if you just go between 2 cells down here, it doesn't work. I will actually have a little fun with this. I was reminding my significant other the other day of this. I helped that person with Excel as well, and she was trying to widen cells down here. I was like, nope, you got to go up here. Don't forget that. All right, so we want to make B wider. We don't need to make it super wide. Like, this is too much. Use your best judgment. And remember that if any of these numbers start taking up too much space and it turns into dollar signs, you can always then go and widen it some more. Looks like column C could be wider. I put in some specific language there, so let's just have everything displayed. Now technically, because there's nothing else set up right now, this is completely displayed, but let's make its column width appropriate anyways, just in case we later went and decided to type something there and it wouldn't be, clashing with each other. Then to the side, so this will be where all our data is going, and we're starting in the year 2020. You don't need January 1st or anything like that. And remember, if you highlight a cell and then you grab the fill handle, you can drag it down, but right now it's just going to repeat that because it doesn't know I'm talking about a year and I want it to increment. So the 2 options are, I can grab the fill handle, I'm holding my mouse, then hit Control. I'm holding Control on my keyboard now. You might even see an extra little plus sign if you look really closely right over the mouse cursor. See, it's gone, now it's there, now it's gone. This is me holding and letting go of Control. All right. So I'm holding Control down and my left mouse as well still. And we got to go down to the year, I think I said 2035. Now you might say, oh, well, 15 years later, but if you only go this far, you're only getting to 2033. That's because the first one wasn't a 1, and actually the entire first row doesn't have a number up there. So I just needed to go a little more. So undo, fill handle, click and hold the Control button down. So let's go down, and if you actually look carefully, if you look to the right of that green border, it shows you what the very last one is. So I'm looking at that, it says 2034, 2035. There we go, I let go, and boom. The other way would have been to have typed in the 2021. Highlight both of these cells. Now Excel will figure out the pattern on its own without you hitting Control, fill handle, click and hold, drag down, and again, you can see there's the 2035, let go. Let me confirm that that's what I said. Yes, 2035. Okay, so starting salary. I could type the $25,000 here if I wanted, but I want my beginning information to the side somewhere. So let's say hiring salary, go here. Then we'll get his raise rate. And that should be the only 2 things we need. We're not going to need to convert this to a monthly amount. This is not a loan. This is something we're only getting the raise every year. When you get a car loan, that's monthly. When you get a home loan, that's monthly. When you pay your credit card, that's monthly. When you get pay raises, usually it's yearly if you're lucky enough to get pay raises, which if you're a state employee, you're not getting one for another 2 years. Thank you, Corona. But that's okay. Still got a job. Not complaining. So hiring salary, we said 25,000. Now I could type the dollar symbol if I wanted to, but I'm not going to. I'm just going to type the 25,000. But then I'm going to go back to that cell and format it as currency, or specifically accounting. That's the default one here. And that's fine if you actually choose the currency one from below and under more options, or from this menu, those are fine as well. It just changes the spacing. It doesn't really do anything else important for us. And then the raise rate, we said we were getting 3%. So our boss is nice enough to give us a little more than inflation on average. And again, notice I keep saying on average. Now I type 3%. If I just type 3 and then I go and change that to a percentage, well, that didn't work, right? And that's because I did something wrong. I don't have the cell active. So let's undo. Let's make the cell active, and spoiler, something's still going to be wrong. When I click percent, it's going to go 300%, and our boss is not giving us a 300% raise unless you just completely reinvented the company and brought us from losing $7 million a year to making $100 billion a year. Then you're getting a 300% raise. That's because 3 as a decimal is not 3%. 0.03 as a decimal would be 3%. So let's undo. Let's just type this as 3% out of the gate. Again, how you're doing these is your choice. I'm showing you lots of ways to do things. Starting salary, let's just link this, equals. And I'm going to do it wrong initially. You know that's the way I like to do things. So this is wrong for now, and I'll even spoil why. We're going to need a cash symbol. So there's our starting salary. Actually, I'm sorry, this is not wrong. It's the next one that'll be wrong because I'm not going to be dragging this down because of the linking. I need to correct myself on that. Later, it'll be wrong, but for now, we're fine. The raise. Now, I don't just type the 3%. I don't just type equals and click here. That's not it. We're supposed to be taking 3% of the base being the starting salary. Now, it's really supposed to be the salary of the year. This year, it happens to be the starting salary. But next year's raise will be a little more because our salary will be a little more. So I don't just say 3%. I don't just do this. That would be wrong. We got to say equals this amount. Now, this is where that dollar symbol is going to ultimately go, but not yet. Times, let's say, times the 25,000. Excuse me. And 3% of 25,000 is $750. Remember, you can always pull out a calculator and confirm these if you don't trust them. And I highly encourage you to do so, especially at first while you're having a harder time of confirming that things make sense. But there we go. 3% of 25 grand, excuse me, is 750 bucks. Then our new salary should be the sum of what we had before, what we were making before, plus the raise. So this will be equals. You can use sum and open the parentheses if you want, but this is just more tedious considering we're adding two things. So instead I just go equals, click this cell, plus click this cell. Instead of clicking, you could have typed. Instead of doing it that way, I could have gone equals sum parentheses B2 colon C2 close parentheses. This is good enough. This looks like it makes sense. It's the sum of these two things. Now, I've mentioned this several times in class already. You get the fortune of hearing me say it again, either fortune or disfortune, depending on if you like repetition or if you've already got it. You cannot just drag this one down. If I drag this down, this is where I was saying earlier would be wrong. If I drag it down, it says 0.03. What? That's because if I double click, we can see what it's referencing. So we had said it was supposed to be 25,000 up here, and when I fill that formula down, Excel wants to move that reference down. So the blue box is moved from here to here. But these are two completely different things, unrelated to each other in any way, shape, or form. That's not what it's supposed to be. And if that raise rate hadn't been there, it would have just been 0. It would have been a dash, and our starting salary isn't dash. It's supposed to be 25,750. So this is that extremely common linking of new to old. The new old is the old new. So I have to start this one from scratch. Again, this is very common. You will see this throughout the semester. I don't even want to say a percentage of the time because, I mean, we just do this stuff kind of intermittently. So make sure that the new salary from 2020 is the starting salary of 2021. So just link there. So this cell is now that one. Boom. The number's correct, $25,750. Now, this is the only thing that you actually have to redo. These other two formulas are potentially correct, and you can just fill them down. So potentially correct, fill it down, and I get something that I didn't expect. It doesn't make sense, does it? We shouldn't be earning a $0 raise in 2021. We're not a state employee. We're my math lab employee. We're getting that 3%. So we double click to see what's gone wrong. Okay, red box is correct. We should be taking our current salary and multiplying it by a raise rate. So the red box is good. It needed to move down. But the raise rate was supposed to be this box. The blue one moved down, and we don't want it to move down. So Excel doesn't automatically know this. It doesn't just say, hey, there's nothing here, don't move it down. It says, you need to tell me not to move down by putting that cash symbol, the dollar symbol, in front of a row, a number, or both, depending on what it is. And per discussion in class, we said to make it not move down, you have to put a cash symbol in front of, let's see if we can figure it out. We want this cell to not move at all. We don't want this one moving at all. I don't want to go on right. I don't want to go on down, left, or up. So while technically speaking, I can get this right by only putting a cash symbol in front of the number, because we don't want it moving down, and that's what it's naturally trying to do, then we cache the number so that one won't move. But just typically when you have these numbers off to the side, not part of the main table, typically we just cache it both ways. So that will make the red box not move at all, right? Is that what we wanted? Is that what we wanted? Question mark inflection? Well, that didn't work, first of all, because I didn't redo the original formula. I redid this one. So again, typical, I'm leading you along on a wrong path initially. So let's undo that. Let's go back to the original one, double click. Red box good, blue box good, but we know the blue one would be moving down. So let's put the caches in front of the reds. Wrong, 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 wrong. So that looks right. But you can't always tell that it's wrong until you start filling it. When you fill it down, that's wrong. When you double click that cell, the red box didn't move and it was supposed to. The blue box moved and it wasn't supposed to. So that tells me I cached the wrong feature. So we will undo after hitting enter. We will redo this formula, and instead of putting the caches with the red, put it with the blue. We hit enter. We still get the same number originally because in the original formula, the caches don't affect it at all. It's only when you start filling it right or down. We finally have an answer that makes sense. You might think this was supposed to be exactly 750, but the reason this makes sense is our base salary for 2021 is bigger, and 3% of a bigger number is a bigger number. If you don't trust that, pull out the calculator. So $25,750 times the 0.03, and there we can see our raise is $772.50 as it should be. So it makes sense. Our new salary is adding these two numbers. I think it's pretty easy to tell that it looks pretty good. If you don't trust it, once again, and this will be the only time I confirm a sum, 25,750 plus 772.50. Technically don't need to type the 0 there, but happy to. 26,522.5. It is perfect. Sweet. So with this stuff involving percents, either raises or interest rates on savings accounts or boat loans or home loans or car loans or anything, it takes 2 completed rows to be able to highlight everything and just go ahead and fill down completely. I don't want to see that yet. Again, the first row is necessary to establish everything. You're establishing the percent formula and then the sum, or subtraction if you're making payments, which we'll get into later. It's this right here, the linking of the start of 2021 to the end of 2020, or month 11 to month 10. This is entirely the reason why you have to have 2 completed rows. So this one was just, I could have typed 25,000 or use the cell reference. So that way, if my hiring salary, maybe we're getting a better job, maybe we make $40,000, and now we can say, hey, all right, well, that just changes our raise to $1,200 for the first year, $1,236 for the second year. Our new salary is growing quicker and quicker. but we're going with Bob's problem. So now that we have the old and the new linked, we were able to drag the raise or interest formula down, the sum or difference or whatever it might be for the relative problem. We can now highlight the entire row. I skip highlighting the year since I already took care of that. Grab the fill handle, click and hold, and you can just do a couple years if you want to. Maybe you just want to see, oh, what's 2022? Click and hold 2023. Or you can say, well, I only really care about that last year. Boom, there we go. So Bob's starting salary was $25,000. And then 15 years later, after several 3% raises, he's now earning $40,000 and some change, $40,117.66 specifically. These raises each year get bigger and bigger and bigger and bigger and bigger. Because our salary for the year is getting bigger and bigger, our raise is a percentage of the salary, so that's going to keep getting bigger and bigger. So, what happened there? Let's see if I can do this. We'll Excel copy over to Word. It copied it weird, but that's good enough just for me to type the number. $40,117.66. So that's how much money Bob will make for the year 2035. So now, part two, what if? Remember I mentioned that whole what if analysis? What if Bob didn't make 25,000? What if Bob started out making, what if Bob started out with a better position, making 40K per year? What is his ending salary 2035? Another what if. What if Bob started out blah, 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 making, and same rest of it. So call it parts A, B, and C, if you will. Now, the cool thing about Excel is all I got to do is change one and only one number the way I've set this up. I'll give you a second to look at that. Okay, so 40,000 and 60,000. Excel, here we go. So I'm not going to change it here. I could go ahead and put the equals 40,000 if I wanted to, but then what I'll end up having to do is change some other things later potentially. If you've already got this set up to the side, why not just go ahead and change the 25,000 here, 40,000. Now that entire table of numbers is going to regenerate as soon as I hit enter. The raises will go up, the new salaries will go up. Drum roll, and look at this. Now Bob's ending salary is $64,188.26. $64,188.26. I'm just going to leave it looking a little silly so I don't have to retype everything. Okay, well, what if Bob made 60 grand? What would his ending salary in 2035 be? Now, what some people might say, okay, well, he made an extra roughly 15 grand here, going from one to the other, maybe like an extra 24 grand here. Maybe they'll try and figure out the pattern that way. Maybe you can, maybe you can't. I'm not saying which is true for now, but what we can do is the same thing we just did. Change one single number in Excel. So instead of the hiring salary being 40 grand, in fact, all I got to do is I don't even have to change the whole thing. I can just backspace the 4, change it to a 6, and drum roll. We hit enter. Boom. Now we're almost making 6 figures in 2035. This is a $36,000 difference. So what some people mistakenly might think is, all right, well, if it's a $15,000 5 and ending at 40, then that raise, that dollar amount's going to be the same, but it's not. You make an extra $24,000 roughly, I'm rounding to the nearest thousands. If you start at 40 grand, you make an extra 36 grand if you start at 60 grand. So your base starting salary plays a very important role in how much money you're going to make down the line. Because if you have a job or a career where all they're doing is giving you 2% raises every year, if you start at 40,000 and your buddy starts at 50,000 for whatever reason, whether it's fair or not, okay, there's a $10,000 difference now, but 15 years from now, it's going to be a bigger gap because of that base salary. And there's a lot of career advice people will give, and they'll say, you know, you shouldn't stay in the same job for more than 3 or 4 years because your salary stagnates. You get better raises by getting competitive offers and going somewhere else. And, you know, while that's probably true for most fields, it might not be how you want to approach. You might just be someone who wants to have one job and work there for 30 or 40 years because you really enjoy it. Salary isn't everything. And those are the decisions you make. But when you get into a real career where you think you're going to be in this game for 10, 15, 20, 30, 40 years, that is something to consider. You know, how long you're going to stay at one place, especially if your job is not offering competitive raises, especially if there is inequality in starting salaries between two people. And I don't mean someone who's 25 and has been there for a year versus someone who's 50 or 58 and been there for 30 years. That's different. That person who's 50, 60, however old, they're probably going to be making more money than you because they've had time to acquire all these raises if they have a job where they get those raises. So yeah, this is a really cool example that I usually don't have too much time to do in QR. So I'm happy to have been able to bring this to the table because not only is it very, very tangible for us, we can also just use basically the exact same Excel format we were doing for that TV loan problem. There was one more variation I wanted to do this. Let's just take this, let's go back to the 25,000. And let's see how long it takes us for to double our salary. So question 2, with the previous example in mind, how long does it take to double? How long roughly does it take to double salary? And then a second part of this question, does this depend on your starting salary? How long will it take you to double your salary? And we'll run through this with the 25,000, the 40,000, and the 60,000 result inputs, that is. And we'll see if one of them's like 25 years, the other's 22 years, and one of them's 49 years. Let's see if it depends on the starting salary. So double, that means if we start at 25, we're looking to make 50. So in 2035, we're only at 40,000, that's not doubled. And let's actually hit the 50,000 number. So if we get a year where it's like $49,999.99, we're not going to say it's been hit. We need to see 50,000. It's likely to be more than $50,000 that year, but again, let's see when we actually hit it. So I'm going to highlight all 4 of these cells because we need to extend the years as well. And generally when you do this, I won't need to use the control. I won't need to highlight multiple years. This should work because it sees the other information and figures out that you're doing this year by year thing. Excel is kind of smart, but sometimes not smart enough. It just depends on what you give it. Now, how far do I need to go down? I don't know. Let's try 1 year. I'm going to 41,000. Well, our interests are gaining at about $1,000 each, so I probably need to go another 8 or 9 years. Spoilers, that would be too much. But if you just keep doing it one at a time, this could get tedious. Maybe you even go, whoops, I clicked something I didn't mean to. Maybe you even go too far. Maybe I just go, oh, let me do this for 50 of these. We're definitely too far. We've now multiplied our salary by 4 times. So let's undo. We got it highlighted, grab the fill handle. Let's go down another 7. 1, 2, 3, 4, 5, 6, 7. Probably too far, but let's see. Yep, just a little too far though, but that's okay. This is just TMI, but not TMI that's bad to have. This is where we finally hit 50 grand in 2043. Now I didn't ask in what year Bob would have his doubled salary. I said, how long would it take? How many years would it take? So if we started in 2020 and we're ending in 2043, that means it would take 23 years to double. And that's at the $25,000 salary starting out. Oops, there we go. So that's when we started at 25 grand. It took 23 years. Let's now change the starting salary to the 40,000, and let's see if this is a cause and effect relationship or if it doesn't matter. Hiring salary is now 40 grand. I'm not going to delete anything over here because if it is correct, then we'll already have as many rows as we need, or as many columns as we need. Rows, rows, rows. All right, so we can see that in 2035, we still have that $64,188.26. And we're trying to hit 80,000 as our magic number. Now, we don't actually hit 80,000 exactly, which is very typical, but we do hit 81,000, which means we have finally doubled our salary. And look at this, it's in the year 2043. So that's kind of interesting, pun intended, that we double our salary the exact same time. Maybe you're thinking, all right, well, if we start with 60,000, it might be the exact same. Maybe, maybe not. Let's see. So there's our 60,000 salary. Our 2035 year is good, the same as it was last time, 96 and some change. And look at this. 60,000 doubled is 120,000, and 2043 is the exact same year we get double our salary. So does it depend on the starting salary? No, it doesn't. So it's not just at $25,000, it's at all starting salaries. So if you start out making $2 a year, it's going to take 23 years to make $4 a year if this is how you're getting your pay raises. That sounds awful and really doesn't exist. If you're making $10,000 a year, it's going to take you 23 years to double at 3% raises. If you're making $50,000 a year, it's going to take you 23 years to double if you're getting 3% raises. If you're making $1 million a year, it's going to take you 23 years to double your salary at 3% raises. So when you look at a concept like this, the base value doesn't really have anything to do with the growth structure. It's this doubling time or tripling time or quadrupling time that holds true. And in fact, let's go on and say, how long would it take to triple the starting salary? How about quadruple? Now, the statement holds true. It won't matter whether we start with 25,000, 40,000, or 60,000. The number of years will be the exact same for these answers. I think we've established that with example 2 already. So let's just go back to the 25,000 as our starting salary and see when we hit 75,000 and 100,000. And then let's also ask, is this time shortening or lengthening? Or the same? So we're going back to 25K. Sticking with our 3% raises consistently every single year, no matter what. Hard to do in the real world, but maybe you get that job. Kudos to you if you do. So we know it took us the 23 years to get to 50,000. So now we're trying to hit 75,000. So now we're getting about $1,500 in our raise. So every 2 of those is 3,000, and we're looking to make another 23,000 from here. So I don't know, maybe like 8 more years. Let's try another 8. 4, 5, 6, 7, 8. This may be too much and maybe too little. I'm just guessing. Still not enough, right? So I did my math incorrectly intentionally for that. So we still haven't hit 75,000. So we just keep dragging down. You know, you can just do this randomly if you want, and actually on the random, I didn't even mean to hit it that time, but that's fine. We hit our 75,000 in 2057, which would be 37 years in total. So we started in 2020, we're ending in 2057, so that would be 37 years. You just subtract 57 minus 20, more specifically 2057 minus 2020, and you get 37 years. So 37 years quadruple. Let's hold off on the last question until we get to quadruple. So we know we need to make 100,000 now because quadruple means 4 times. 4 times 25 is 100 grand. And let's skip the math and just see if we can drag this down and hit it. Not quite. Ooh, what did I do wrong? I didn't grab the fill handle. So I grabbed the outside border on accident, so we undo. Make sure we're grabbing the fill handle. Precision is important. We're getting closer. Grab, hold, drag, let go. There we go. Just barely made it in the year 2066. So from 2020 to 2066, that would be 46 years. So it took 23 years to double our starting salary. Then it took 37 years to triple our starting salary. Then it took 46 years to quadruple our starting salary. Again, all of those are in reference of the 25,000. And it wouldn't have mattered if it had been 40 as the starting or 60 as the starting or any dollar amount. It's just the same for all examples. So is this time shortening, the same, or lengthening? Well, if it was the same, that means it would have been another 23 years to triple, meaning 46 years in total, and then another 23 years to quadruple, meaning 69 years worth of employment, which nobody needs to do, I hope. So this time is definitely shortening. It's actually shortening more and more as time goes on. We don't really hope too many people are working past 46 years in the workforce from, say, post-college age and on. Some people like to work 50, 60 years, and that's up to them. I'm not really in that scheme of things. I'd like to retire and have the option of doing things on the side for fun. But if I didn't, I could live. I love teaching. I love doing stuff like this. I hope to be able to do things like this for free one day. It might be another 50 years. But I'm a little bit of a geek. When I'm with friends and family, I would say I'm talking about stuff like this 10, 20% of the time. I love it. So, 1 year, I'll do it for free, but not while I still got to scrap and earn. Let's see how this effect would go on if someone did continue to work, though. So this is year 46. Highlight them all. Let's see when we'll make 125 grand. Still not quite. Still not quite. Almost there. Maybe one more year. There we go. So now we've quintupled. That means 5 times as much in 2074, which would be 54 years. So only another 8 more years to make your starting salary on top of what you have. So in other words, to your starting salary of 25,000, you get another one of those 23 years later. You get another one of those in another 14 years. Then you get another one of those in 9 years. Then you get another one of those in 8 years. So the time for you to make another 25 grand keeps shortening and shortening and shortening. And if you worked for 200 years, eventually you'd just be making that extra 25 grand every year, or maybe even quicker than that. What's important about this concept right here? It means that the closer you are to retirement, the bigger your pay raises are, the higher your raise feels relative to when you started out. What it's also important of is the idea of compound interest for retirement planning. This idea of you gaining more and more money over time directly correlates with your retirement planning. A lot of people thinking, oh, hey, someone told me I can just put $100 a month away and eventually I can retire and be a millionaire. And that's roughly what I'm going to tell you in my Math 154 class, but in a more fun way if I haven't already mentioned it. We will do the math in Excel eventually. But you go $100 a month, that's $1,200 a year. That's not a lot of money. If I work for 30 or 40 or 50 years, that $1,200 times 30 or 40, 50 years, that's not even 100 grand. How are you making me a millionaire? Interest. So you put this money into accounts that earn 7, 8, 9% interest, hopefully. And when we talk about investments like that, they're not guaranteed rates and they change every day for various reasons, because there's stocks and things like that. Stocks, bonds, all sorts of other things, whatever. Not the point of the problem, but yeah, your first 10 years, maybe you only make a couple grand in interest, but you get this snowball effect because of the more interest, then you'll get more interest on top of that. And you could also say, all right, well, I'm putting $100 a month away when I'm 22. When I'm 62, I can probably afford more than $100 a month because I've been getting these 3% pay raises. I should probably adjust my deposits to inflation or to my raises. So now instead of putting $100 a month away, maybe you're putting $229 a month away. So you get this snowballing effect where, yeah, it just doesn't seem like that much at first. Yeah, this is okay. This is fine. I'm making good money now, 23 years later. But then all of a sudden, it just takes off eventually. And it's this rate right here that has a drastic effect on that. So this rate, what if our boss was giving us a 4% raise every year instead? How would that affect these doubling times and how much we'd make the 15 years later? So let's just go from 3% to 4%. We're just kind of having fun here. So now our raise is now $1,000. We just made an extra $250 that first year. And then that raise is going to keep getting more and more raise-like, more and more money, more money, more money, more money, more problems around here. No, sorry, it's a joke. So in 2035, now we're making almost 47 grand instead of the closer to 40 grand. The doubling time of, we're starting at 25, so we need to hit 50, is now in 2037. It's only 17 years later instead of 23 years later. We just shaved 6 years off the doubling time by making a 1% increase in some way. Now, was that an option we had to choose? It just depends on our career. Maybe you find a job that can guarantee this 4% every year. I certainly find that hard to find personally, but those jobs do exist. Medical field, there are earners. Politicians, there are earners. Yeah. Look at this by the time we make it to where we were before when we had quadrupled or quintupled. I think we had quintupled by then. We were at 125. Now we're at 216. We are now making more than 8 times our base salary 54 years later. Now, if you're only going to work what was the original quadrupling? Let's go to the quadrupling. Time. Getting there. Okay. So the 46 years to quadruple, there's a decent amount of people that are going to work 46 years. I actually think the 37. I want to see y'all only having to work 37 years. So you start out at 22, you work till you're like 60 roughly. If you want to say at 66, if you start out at 22, that puts you at 68. That's actually a lot more appropriate for a traditional retirement now at 67. Maybe we should stick to the 46 because of that. But I'd still love to see y'all all retiring at 37, or at least having the option. And, you can stay in the workforce and continue to make a load of money and let your investments continue to grow. All right, so we've quadrupled 46 years in. 46 years, that was year 2066. We're now at 157, which means we have sextupled. That's 6 times the base salary and then a little change. So we're making an extra 55, 56 grand on top of what it was before, just by making a slightly higher raise. So this number plays an absolutely critical role, especially in your investments. You can't necessarily control it as much here with your job unless you're specialized. But with your investments, you can by playing it more aggressive. If you go and invest in a bunch of bonds, you're getting 3 or 4% a year. And that's not going to be great for your retirement portfolio doing that the whole time. If you're playing it more aggressively and doing a mix of bonds and stocks, maybe you're getting 7 to 8% every year, which is the traditional average, as you'll hear me say in Math 154. If you invest super aggressively while you're young, and quite honestly, it doesn't matter if you lose half of your butt 10 years in because of the housing market crash of 2008 or because of the COVID-19 crash of 2020, which is already basically undone itself, although tech is correcting right now currently. I watch this stuff daily. I'm a bit of a fanatic. And a lot of people say, don't watch it every day because you'll have a heart attack watching your money disappear occasionally. And that part's not fun, but I also just love numbers, so I have to. But the difference of 4% and 7%. So let's say this was your retirement planning. And okay, you quadrupled your base with this 4% in about, 35 years? That's pretty awesome. Check this out. If this was just bonds, again, we're using kind of a side problem now. Now this is just some money we put away, $25,000 to retire on. But if we invested this in bonds and stocks and got that average 7% expected return, expected, not guaranteed, now instead of quadrupling our money in the year 2055, when I hit enter, watch what that cell goes. Instead of 102,000, 20, what did I say, 55? Now it's $285,000. We have multiplied our starting salary in 35 years by almost 12. That's 11 times. And again, now I'm thinking of this as a deposit, not a salary, because we're likening it to retirement. But that's investing in bonds and stocks. More bonds when you're older, more stocks when you're younger, play it more aggressive, and you can get higher yield returns. Maybe you're really good at investing and you get a 10% average lifetime return. Holy cow, look at how much money you got in 2055 now, $772,000. And all this was a $25,000 initial deposit. Now, that's not how you retire. You should be continuing to add money to that pile every month, every year, as long as you have that ability. I know some of us don't have that ability, but hopefully with our budget project that we'll likely do, maybe that'll make you learn to be a little more fiscally conservative and understand a way of retiring. Because as I think I've said, they don't teach this stuff in middle school. They don't teach it in high school. They don't teach this in math classes. If you go and get yourself a math degree, a 4-year math degree from pretty much any school in Virginia, they're not going to teach you about these crazy inflation rates in a finance way. They'll teach you the concept in much more convoluted applications. But I will admittedly say, I never saw any of this type of thing when I got my math degree. Now, if I had gotten a business degree, I would have seen it day one practically, probably. But it's just amazing how some of these things are so important for us that they don't teach us as kids, teenagers, young adults. And that's why we have, unfortunately, like 80% of the workforce that when they hit retirement age is not ready to retire. And they go, okay, well, I'll just get Social Security. Social Security is a small check. That is not a retirement check for most of us unless you were already making hundreds of thousands of dollars a year. Because Social Security is based on the amount of money you've earned over your life. Social Security was a fantastic creation in theory was it part of the New Deal in the 40s, the late 40s, something like that. My history is a little rusty. But unfortunately, it was based on two factors that we were supposed to be helping the poor people, but ended up helping the rich people more. And that is your Social Security is dependent on how much you've made. So if you've made $10 million of your life, your Social Security pile is giant that you can now collect. If you made $100,000 over your life, your Social Security pile is teeny to collect. The other thing is, on average, rich people live longer than poor people. So those rich people get to collect their Social Security for maybe 10 or 15 more years. And again, I'm not naming anyone specifically. I'm just naming these averages that are true. You can Google them. I know I'm not showing you hard data on the screen, but this is information that you can go and research yourself. That typically, richer people tend to live longer. They can afford more, medical stuff. They can get hearts replaced and all sorts of things. Maybe in 10 years, part of a brain replaced. I don't know. But if you can't afford a heart replacement, there might be a sad story in the paper in the next day or two, It's unfortunate. So Social Security is nice that it's there. In 10 or 15 years from now, 30 years from now, will it still be around? Will it be partial payments that we're getting? I'm not going to make any arguments for either of those sides. You might be able to guess what my opinion is, but it would be an opinion, and I don't want to express that in a recording like this. I don't think that that's a fair assessment because I don't want to be that person. But the other things that I said were facts, for sure. So let's see if my math lab is still being stubborn. There was a reason I pulled this up. There's something else up. It's all right. If this is going to be super slow, we're going to just go ahead and cut it. Yeah, it's still being slow. It's not even loading. Yeah, this is just going to be a nuisance. we'll answer this one question, and then I'm just going to say this is supposed to be homework anyways. Quote, homework that's not actually graded. It's your participation, your attendance that you're going to do some of, all if you really want to. But don't do none of it. None of it means you never attended class, because I'm now getting to the point where I'm only seeing 4 or 5 of my students show up every day, which is what we expected. And that's fine, because you can watch the replays. So one question, and we'll call it a day. Mark reviews his textbook to study for his test. That seems like a good idea. In addition to his notes, he discovers that he highlighted everything in yellow when he read the chapter the first time. I mean, literally everything. Highlighters are cool. They emphasize. But if you highlight everything, there's no emphasis. It's exactly as it was before, now just in a bright color. So now he doesn't know what to study. So what strategy would help Mark make more effective decisions about what to study from his text? So we got return to the chapter later to underline what was on the test. Identify the main ideas in each section. Make an outline using each highlighted sentence, or number the paragraphs in the chapter. Got a couple of people saying B. Identify main ideas in each section. Let's go with what they're saying, and let's see if that's right. It's going to take forever to check it. It was right, and that's what I was highly expecting. I'm 99.9% certain, but sometimes this can be a little screwy. So Mark should effectively start over and only highlight main ideas. That's a great idea for highlighting, just main topics. And it doesn't have to be just main topics. It can be super important things that you might be using regularly. So it might not be a main idea, but it could be like a formula that we know we're going to use over and over and over and over and over, or a concept like pay attention and ask yourself, does it make sense? Those would be 2 things I would massively highlight and asterisk and circle and star on my own notes. But this first one is out of the gate, because to underline what was on the test, that's past tense. We were supposed to be studying for the test. So I don't know that that would be that great. Make an outline using each highlighted sentence. That could actually be a good idea, but it might not be enough, and that would be separate from your text. So C was definitely not going to be the answer. Number the paragraphs in the chapter. I really don't see any purpose of that in my opinion, but I won't say it's garbage, because maybe your brain works really well with numbered paragraphs. There are some texts and documents and books that have lines or paragraphs numbered, and maybe you're just used to seeing that. So yeah, so
we're going to go ahead and call it there. Just kind of putting the 154 whiteboard up again, since we had a couple new assignments. Hopefully this was informative. Hopefully this was helpful. Remember to keep up with both of your Math 154 homeworks as well as your MDE homeworks. You should have the week 1 stuff completed, like I said, 70 or higher within, I don't know, I'd say by Monday, Tuesday, something like that. And then about a week later, you should have all the week 2 stuff done. Again, while there are no official due dates, I am going to be looking for grades, passing grades, after several weeks. And if we're 5-6 weeks in and I don't see any passing grades, then that's when you get removed, and we don't want to remove you. So please, please, please keep up with those homeworks. So as always, if you have any questions, you can shoot me an email, or if you have them right now, you can ask. But besides that, we will see you on, what is it, February 1st, January 31st? I can't remember off the top of my head. January 31st, that Monday. All right, take care, everybody.